So, welcome to module 8.5, and in this we will be talking about the syntax or the grammar of the Jack language. We got some introduction of how Jack works, right? Some introduction of while loop, let, do, class, main, and we have seen so many things there, and we have also executed a set of programs and understood what's happening there. Now, we will now start looking at what we call as the Jack syntax, right? The syntax of Jack. And so that's what we will be covering as a part of this lecture. So the syntax elements are, what are the things that are present inside Jack? There are only 6 different things that you see. You will find some comments and white space. You will find keywords. What are the keywords? Var, function, class, function, void, var, array, int, right, let, okay, do, while, right, and these are the things. These are the keywords that you will see. Then you will see some symbols like, this braces, semicolon, dot, right, and then you will see some constants, right, like 0, and then you will see identifiers like a, length, I, sum, right, and this is entire. So this is a constant. This string, how many numbers is a string, is a constant. But then you will see length, sum, a of I, etc. Okay. So there are only 5 different syntax elements in this entire Jack. See, now this is the way you start understanding a programming language. You will be learning Python, you will be learning C++, C sharp, A sharp, D sharp, E sharp, Z sharp. So many things you may be learning in life, R for example, right. The way you approach understanding the programming language in its full glory, right, we need to understand it completely. It's not be half-baked. Now this is the way you start. So what we would, this particular 2 modules, 8.5 and 8.6, slightly dry part of the course, but what you need to concentrate here, and I will try to impress upon you, is that the approach to understanding a programming language. Now in this programming language I have only 5 different syntax elements, nothing more. 5 is something very easy for us to comprehend. Now what is the objective of this? I need ultimately to write a compiler. I have been using a compiler, right. You have, in project 9 we have used a compiler. Now we have to basically construct a compiler of our own. To construct the compiler of our own, we should know what is there, what is it that I will be exposed to. You will be exposed to only 5 elements in this. That is what this particular discussion opens up for us. You will see some white space and comments, you will see some keywords, you will see some symbols, you will see some constants and identifiers. That is all, nothing more, nothing less. So when you are compiling, all your space, characters, new line characters, comments, everything are ignored. The following comment formats are supported. I will have // comment until closing, and an API documentation comment, right. So these are the things. So in the whatever you see as blue are the comments, and these will be ignored by your compiler. So when you start compiling, first when you read the file, first go and remove decomment it completely, right. So many codes, this decommenting is not actually necessary, because when we see the code that is written as a part of many of our even programming languages, you rarely comment, right. That has been a curse of programming, I should say. When I did my BTech, I did not comment. Maybe I did not do that much programming, say for 30 years before. But even today, the amount of comment that is being written is horrible, right. We don't see single comment anywhere. So, that is one thing that will, so ultimately every academic institution in our country would have been graduating so many students, assuming every student has written say some 1000 to 2000 lines of code, very optimistic about it, or very pessimistic maybe, right. So imagine the total number of code that we should have generated over years, right. Now, why are these code not becoming public or open source today, right? We are using lot of open source. This entire course is open source, right? I could not have run this course if Nantu Tetris website is not open source. Now, why are we not able to contribute to such open source? The reason is we don't comment, right? We don't write comments. We don't make effort to write comments. So, one of the things that all of you should start doing if you want to really contribute to the overall growth of computer science and essentially open source software is start commenting, right. So, but that comment is only for the human who is going to read your code and going to enhance your code. But for the compiler, that comment is useless anyway, right. But you write a code for the other user, not for the compiler. So, right. So, first thing in the compiler, this what you call as a syntactic analysis. I'll look at the grammar of your whatever you have written. First step the compiler will do is to decomment it. Now, what are the keywords here? Look at all these blue ones: class, function, void, var, int, let, while. These are all keywords, right. So, what are the other keywords here? So, there are keywords are of 6 types. One is program components, which are class, constructor. In this case, we have not seen a constructor here, method and function. We have seen these things as a part of our describe. Then the primitive types like int, boolean, char, void, and then variable declarations like var, static, field. We will talk about static a bit later, but then field, we have seen this field. Then all the statements let, do, if, else, while, return. Then all the constant values null, true, false. We have seen this null in the list case and true, false. And then object reference, that is this, right. I point to the same object this. So, total number of keywords if you count is 8 plus 3, 11 plus 6, 17 plus 3, 20, 21 keywords we have, that is all, right. Total keywords is only 21. Then coming to symbols, you have just 8 classes of symbols. One which is used for grouping arithmetic expressions and for enclosing parameter lists and argument list, like you see here, right, the opening, closing and opening parenthesis as you see here. Then there is a square bracket which is used for array indexing, and then braces which is for grouping program units and statements for the while loop. It is exactly how C works. Then comma for variable list separator. Comma is used only for variable list separation, nowhere else I am using comma, only in variable declaration I can use comma. Semicolon is for statement terminator, equal to is assignment and comparison operator both, right. So so I equal to length is a comparison. So that is why the what is the difference between this equal to is an assignment statement. Somewhere I can say while I equal to length, that equal to is a comparison. So, how do you distinguish? For this assignment I also have a let statement, that is why I use let here. Instead of in C we use double equal to for comparison and one equal to for assignment. In this case I use equal to for both assignment and comparison, but the way I distinguish between comparison and assignment is by using the keyword let, okay. And this dot is for class membership, array dot new, keyboard dot read int, right. And then all the arithmetic operators which are 9 in number, plus minus star slash ampersand pipe tilde less than and greater than for comparison. So, totally if you say there are each symbol distinctly, there are 6 of this, I am moving the mouse here, 6 of this, 7, 8, 9, 10, totally 19 symbols, right, totally 19 symbols, 21 keywords, 19 symbols. So, the integer constants must be positive and in standard notation. Negative integers like minus 13 are not constant, but rather expressions consisting of a unary minus operator applied to an integer constant, right. So, please understand integer. So, we are now talking about constants. There can be 4 constants. The integer constant is always positive, right, and negative integers like minus 13 are expressions, that is a unary minus followed by 13. String constants are in double quote and may contain any character except new line or double quote. So, I cannot have a double quote inside double quote. These characters are supplied by the functions string dot new line and string dot double quote from the standard library, right. So, if you want a new line for a string, then you put string dot new line, and if you want a double quote, string dot double quote. Okay. Boolean constants can be true or false, small true or small false, they can be, and the null null constant signifies a null reference. Okay. So, these are all the 4 types of constants. Please note, constant is always positive constant, negative constant is an expression. Then the identifiers, let us be very clear here, are composed from arbitrarily long sequence of letters like length, I, A, keyboard, dot. So, they start with A, capital A to Z or small a to Z, and they could have digits in between 0, 0 to 9, and they can have underscore. The first character must be a letter, that is A to Z or small a to Z, capital A to Z or small a to Z, or it can be an underscore. The language is case sensitive. So, small I is different from capital I. Thus, X and X are treated as different identifiers. So, this is about identifiers. So, essentially these are all the syntax elements. So, keywords, symbols, constants and identifiers. Now, we will see the different data types that are part of this. So, I could have int, which are non-negative 2's complement 16-bit integer, that is an integer in the range 0 to 32,767. They are non-negative 2's complement, right. So, 16-bit integer from 0 to 32,767, right. So, 2's complement essentially means it covers positive and negative integers, right. So, when I take it as 2's complement, it will be the value of that will be non-negative for all arithmetic purposes. The interpretation can be positive or negative. So, we have, so I take you back to the module where I taught you about 2's complement arithmetic, wherein a subtraction will be treated, everything is addition, subtraction, both addition and subtraction are treated as addition. So, that is the interpretation of this. So, and you could have boolean which is a primitive type. Instead of int here, I could have boolean which is true or false. I could have char which is integer values representing characters, again 16-bit values. Now, the class types are OS types, which are string and array, which are provided by the operating system. So, you see array here, and then you can have user defined types, like I have defined fraction, I have defined list, etc. So, we could have these user defined class types, right. So, these are all the primitive types of data. The hack character set is given here. So, you need not know completely, but so this is how 32, 33, 34, 35, 47, 0 to 9, semicolon, A to Z. So, all the F1 to F12. So, all the characters of 256 of ASCII may not be needed here. So, the hack character set is defined for this particular system. These are all the characters that are recognized by okay. These are all the characters that are recognized by the hack computer, right. So, for a general system there is a character set. This is ASCII, American Standard Code for Information Interchange. For the hack, this is the character set. So, the type conversion we have already seen, right. If we assign a floating point number to an suppose I say float I and int j and I equal to j. So, what will happen is j is an integer assigned to a floating point number. So, j will be converted to a floating point number and assigned to I. Suppose I say j equal to I can in some compilers will make I, which is a floating point number, it will make it as an integer and assign it to j. So, normally when I am assigning when I am assigning one variable to another variable, the one which is on the left hand side, which is assigned some value, it will be of type A. On the right hand side can be of type B. Type B normally gets converted to type A, or we call casted to type A and assigned. So, this type of type conversion can also happen in the case of Jack. So, here the characters and integers can be converted within each other, like var char c. So, this is how you define a character. Var string s, this is how you define a string. C equal to 65, let C equal to A, both are same. Let S equal to A or let C equal to S dot char at 0. Char at 0 is A, and if you go to the character set, S dot sorry, if you go to the S dot char at 0, the 0th location capital A is stored, because S has S is a string, S of 0 will be A, S of 1 will be null, right. Let S equal to A. Now, the char at 0 is A. So, C equal to S essentially means this. So, so char at suppose I define a string is an OS, as we see here, string is an OS type. So, the string has lot of things inside. We'll look at that in great detail, but just to tell you here, one of the function, one of the method inside a string is char at. Char at location. So, the char at location 0 is capital A, and that is a character which I can assign. So, this is the way I can play between strings and characters and integers, interoperability between them. An integer can be assigned to a reference variables, in which case it is treated as memory address. For example, var array equal to ARR, ARR is equal to 5000, means ARR 0 is stored at 5000 address. So, this is a memory address. ARR of 100 equal to 17. That means, where is this 17 stored? 5000 stores ARR of 0. So, 5100 will store 70, right. So, so this is how I can assign. So, if I say var array ARR, just ARR, this is also equivalent from C, we have borrowed it from C only, just ARR is the starting address of the first element of the array, that is 0th element of the array. So, when I say let ARR is equal to 5000, ARR 0 will be stored at 5000, ARR 1 will be 5001. So, when I say ARR of 100, as you see, is equal to 17, so 5100 will store the value 17. Now, another type conversion is var array ARR. Let ARR is equal to array dot new of 2, right. ARR 0 is equal to 2, ARR, let ARR 1 equal to 5, right. So, this is how. So, I have declared an array ARR in which there are 2 elements, and the 0th element I have made it 2 and the first element I have made it 5. Now, I have var fraction x, right. The moment I say fraction, again that also requires 2 integers for numerator and denominator. I can say x is equal to ARR. Let x is equal to ARR means this is like pointer aliasing. this x also is a pointer to a location as we saw in our implementation. X is a pointer to a location from which there are two integers that are stored. Now we say let x is equal to ARR. Now I have aliased this ARR and x, right? I have aliased this ARR and x to point to the same thing. So this is something like we can call it operand overloading or casting of pointers, both are same, right? So this is x is equal to ARR. So now I say x dot print, it will print numerator as 2 and denominator as 5. It will print 2 by 5 here. Now how does a class look? The class actually has this is class foo. It has field variable declaration, it has static variable declarations, then it has subroutine declarations. In the subroutine, so the field and static must precede the subroutine declaration. What is static we will see slightly. So each class is stored in a separate Jack file. So for every class I have a Jack file. And this is the naming convention. If the class name is foo, you call that file as foo.jack. So if I have main.jack, the class name inside that will be main. If I have square.class, the class name inside that will be square, etc. Right? So and similarly subroutine declaration. So there are three types of subroutines. I could have constructors, I could have methods and functions. We have basically distinguished these three in our example. So just to take you back and show you one example here. Suppose I go to the projects and let us take the square. So there are three Jack files, the square game.jack. Now you have the class called square game. Inside square game.jack. Similarly, if you say main.jack, this main.jack, you have the class called main. Similarly, you have square. You don't have anything else. You have this. If you have the square.jack, you have a class called square inside and nothing more. So this naming convention you need to follow as a part of. It will be followed as a part of every Jack program. So so these are all the APIs that are already available as a part of the operating system is giving you these libraries, the math.h you are using right in your C. Similarly, what will be our math.h? So I will have ABS, absolute value, multiply, divide, min, max, square root. These are all there already. So this is called utility class. And there will be no constructor or methods for this. They are basically static methods. They are just methods, they are function ins, and so we can use them. So this is a library of services like how your math.h, we can use this. Then we have fraction, list, string. These are also these are all classes that will have at least one method and used to represent an object type, and operations can also contain functions recommended for helper purpose only. So all these things. So we have seen this fraction, this string, etc. So we should not mix this library functionality and object representation in the same class. Okay, so this is different and this is different. This is object representation. Okay. So this is a very bad example. In our fraction itself, we had a function, right, which is an utility function. Right. Instead of doing it, so it was as a part of the fraction. So somebody has to instantiate a fraction to start using it, and nobody else can use it from outside. Only this fraction.gcd can use it. Rather than, I could have had another class math, right, which has this function in GCD, and I can say math.gcd, right. So because GCD is a common function across many languages, across many objects, right. I am not using GCD just for reducing fractions. I can use GCD for say some cryptography or some number theory computations later, right. So this is a very bad design. So, I have put this GCD inside a fraction and I am using it, rather than I could put GCD as a part of the math library of mathematical function and just say math.gcd. Then this should have been very useful for us. Okay. So, so in some essence, there was one small correction to what I told in the earlier things. A function can also be used by an external user. It is not that only method, I told only methods can be used, but a function can also be used by the external user. So, this is a math class. So, this concept of trying to move out unnecessary things or generic things into a common library, that concept is called refactoring, right. So, refactoring is a way by which the size of the classes gets reduced and irrelevant or more generic things actually move out into a better class, into a class of functions. So, that is something that we need to keep in mind, right. So, finally, we come to the Jack application. A Jack program or application is a collection of one or more Jack classes, one of which must be named main. The main class must have at least one function named main, and the program's entry point is main.main, right. And this is so what does the OS do here? The OS gives you a lot of things, like for example, array, it creates a space for array.new, it creates space for you. Keyboard.readint, it allows you, it interfaces the keyboard with the program. It interfaces output.print.string, it interfaces the screen with the program. So, what you see here is the purpose of having an OS. It closes the gaps between high level programs and the host hardware in some sense. It provides efficient implementation of commonly used functions, like your math functions can be part of your OS, and also all your allocation of memory and etc. Provides efficient implementation of commonly used abstract data types like your int, etc. Right. And the OS would be, OS in turn, OS itself is a software, and how do you implement a OS? It will be a collection of classes similar to Java standard class library. Like keyboard is a class which has readint, read string, etc. Array is a class where it has new, dispose, etc. Output is a class which has print string, print int, print ln, new line, etc. Right. So, OS itself will be a collection of classes. We will see in project 12 some very good implementation of OS routines. So, the Jack standard class library, which is provided by the OS, like what you see, your stdio.h, math.h, string.h, all those things that you see as a part of C language. So, OS also, the Jack OS also provides math, string, array, output, screen, keyboard, memory, sys, etc. So, we will see some of this. The complete OS API is available as a part of your project. We will show you very shortly on this. The last thing is about methods. So, class foo, some name foo. So, we have field variable, static variable, and subroutine declarations. Now, we are talking about subroutine declarations. So, what are the methods here? There are three types of methods. One can be a constructor, a method, or a function. The subroutines can be of three types: constructor, method, or function. And then you have a subroutine name followed by the parameter list. Then inside you will have local variable declarations, statements, etc. Right. So, what are the Jack subroutines? Constructors, which will create new objects; methods, which will operate on the current object; functions are static methods which can be used also, which will not change the content of the current objects. Right. So, the static method will not change. It will basically it will take some values and give you a new value, and the methods will use this function to change the context of the current object. Right. So, the static methods means that the function will take some value, compute a new value, that this function will not change the content of the different local variables inside the content of the different fields inside the class. That is why we call it as static methods. So, for example, so the subroutine types and return values, we could have method and function type can be either void or a primitive data type or a class name, right. So, and each subroutine must end with return some value or just return. So, when it is void, you just say return. If it is some primitive data type, you say return value, or if it's a class name also, you return some value which is that of the same class, right. Now, the constructor basically looks like this: constructor, class name, constructor name followed by parameter list. So, this is how class point. So, I want to declare a point, it has field int x, int y, constructor point new int x, int ay. So, whenever I call when I declare say okay, some point A, point P, when I say P dot new of 2 comma 3, the x coordinate of P becomes 2 and y coordinate becomes 3, right. And every time this returns this object. So, if you create A dot new, it will return that object A itself, that is why we say return this. Okay. Now, we have the variables again inside this, the local variables can be of the total number of variables inside a class can be of 4 types. There can be field variables which are belonging to the class, then there can be local variables that belong to the function, right. This in blah. So, this will be belonging to this function, it will just do after this method goes, it will go off, right. And then there are parameter list like int z, etc., which will be supplied to this function. Then there are static variables which are like point count. Suppose I am class point basically is going to declare some set of points, right. I am going to instantiate number of points. At some point I want to find out how many points I have instantiated, right. So, that is how I have this static int point count. So, I have a class point and I want to create say 100 points, 1000 points, 10,000 points, many number of points. At any stage I want to find out how many points I have created. So, I will have the static int point count. Whenever I am constructing a new point, right, I will say point count equal to point count plus 1, and that will be remembered, right. This x and y are new for every time I am creating a point, this x and y will be taking the value of that new point, but this point count will be remembered. So, every time I create a new function, I can say point count equal to point count plus 1. At any point anywhere in the program, I can ask this point dot point count, and that will tell me what is the number of points that are basically instantiated till that point. So, this is what we mean by a static point count, static int point count, right. So, we have been talking about static variables, where those variables originate. These are the ways by which they originate, right. So, there are these 4 types of variables: field, static, local and parameter. The variables must be declared before they are used. So, I have to declare int x, y, I can't use it just x, y and then later declare, and the variables are strongly typed, right. So, the static variables are declared in the class declaration. This is the class within the class, right. So, static variables are declared in the class declaration, field variables are also declared in the class declaration, local variables are declared within a subroutine, right. So, here, so these are int foo is a local variable, while the parameter variables are in the subroutine signature, for example, blah int inside. So, this is where the parameter variables are declared, right. So, these are the ways. What are the different statements that we see? We have seen five different types of statements. Let is a statement. So, let var name equal to expression, or let var name of expression 1 equal to expression 2, right. Where the var name can be a variable which can be a static, local, field or parameter variable. Okay. And similarly, if so if statement, if expression, curly brackets, statements 1, else curly brackets, statements 2, where statement can be a single statement or a collection of statements. So while there is an expression, then it can be statements, and do a function or method call. So, and return an expression or return itself, right? Now, so this is a very good introduction to what we term as how we formally define certain values. See, I have defined a statement using statements, right? For example, if expression can have if inside this, statements 1, and else statements 2. So, a if statement can have if inside this, because so if is a statement which will contain in turn more statements, which could be if or let or while or do. So, inside an if I could have while, right. So, this is a recursive definition of statements, and this is the beauty. So, this input comes from what we call as theory of computing or automata theory. So, there will be a course that many of you will study as automata theory. When you are studying this automata theory course, you will be subjected to something like what is a regular expression, what would be. So, you will be you will require context free grammar, context sensitive grammar, etc. Right. When you start studying these things, you will be exposed to this recursive definition, and one of the foundation steps of understanding where will you use these recursive definitions. One question you will be asking, why should I study this at all? This is exactly where you will be using such type of recursive definitions, where a statement, what is a recursive function? A function calling itself is a recursive function. Similarly, a statement that calls the definition of a statement includes statements, right? And so that is why this is called a recursive definition, because the definition of statement includes a definition, right? So, I could have multiple statements which could be any one of this inside an if. So, that is how we are using it. So, now we have defined what are statements. Now, we have to go and define what are expressions. Expression is 2 plus 3 into 5 is a expression, 2 plus 3 by 5 is a expression. Just a equal to 2, just that 2 itself is an expression. We have seen here, right? Let var name is equal to 5, 5 is a expression. So, a constant itself is an expression, a variable name within that scope, static, field, local or parameter, that is also an expression. This keyword denoting the current object cannot be used in function, but it can be used in methods, right? This is a expression. An array element using array expression, where ARR is a variable name of type array. In scope, it should be in the scope, scope of the variable. I hope all of you know what the scope of a variable is, right? So, it is within the definition. So yes, so this is an expression. A subroutine call that returns a non-void type, please, because is also an expression. So, I could have if let suppose this is an integer, let I equal to GCD of a comma b, that is a subroutine call, right. So, these are all some basic entities of an expression. Till now we have not seen the word expression itself, but see here, you are seeing this, right. So, the expression is an array in which I could have ARR of 2 into j plus k. 2 into j plus k is an expression, right. So, an expression can have an array, inside that there could be an expression. So, the recursiveness starts here. Now, an expression prefixed by a unary operator is an expression. That is why we said minus 13 is an expression. 13 is a constant, that is an expression. Prefix it by minus, so minus 13 becomes an expression, or tilde expression is also an expression. So, these are all unary operators. Now, I can look at binary operators like plus, minus, star, div. So, an expression, op expression, that is what you are seeing here. Expression, the expression op expression is another expression. So, that op can be plus minus star division, it can be integer or it can be boolean and bitwise or it can be less than, greater than or equal to comparison. An expression inside a parenthesis is an expression, right. Now, the last things that we will be seeing is the subroutine calls. So, I have method void f, I can say so that declares a local variable bar, another local variable primitive type int, do g, this calls method g of the current class on this object. But if I say do foo dot p, this calls a function p of the current class. Do bar dot h calls function h of some other class bar. Let b equal to bar dot r calls function or constructor r of class bar, or do p b dot q calls method q of class bar on the b object. Let I equal to w of b dot s comma foo dot t calls method w on this object. The arguments are the results of calling method s on object b and function or constructor t of class foo. Okay. Okay. So, this is how we see this. So, when I do a method, I say do that method, but when I call a function, I just call it as a function. Function will be an expression, method cannot be an expression. So, what you need to understand, you need to understand this particular slide very carefully, wherein you need to make a distinction between method and function within the same class, method and function out of the in some other class. And where do I use let, where do I use do? Do is basically used for methods, while and you know, the functions are basically used in expression, and we could also do a function of a particular thing. So you have to be extremely careful in understanding how these things work, right. So one of the things that will make a distinction between methods and functions in terms of their usage, right, a better understanding. Now, strings is a class given by the operating system. So, string s char c. So, I can say string dot new 12. So, it will give you a string of size 12. Okay, this is like malloc for a string. Then say let s is equal to hello world. So, this is say something like, I can put this entire thing. So, both of them are same. So, this will automatically put some 12 characters. Now, I can access some character within a string. Let us see equal to s dot char at 6. So, this the sixth character 0, 1, 2, 3, 4, 5, 6 would be w, right. So, it will C will be assigned the values w. C is a character. So, array again, this is array dot new 4, array 0 is 12, array 1 is false. I can put anything in this side the array, and array 2 is equal to fraction dot new of 314 by 100, right, and let r3 is equal to hello world. So, I can do all these stuff here. Okay. Multi-dimensional. So, the Jack arrays are instances objects of the OS class array, and it is not typed. So, I can store different things in different arrays, and they are unidimensional. Multi-dimensional arrays can be obtained by using an array of arrays. Okay. So, the keyword let must be used in assignments, the keyword do must be used for calling a method or a function outside an expression. Okay. The body of a statement must be within curly brackets even if it contains a single statement. In C, if you have a single statement, you cannot and all subroutine must end with a return. No operator priority. So, the following value if unpredictable, for example, 2 plus 3 into 4, to enforce priority of operation use parenthesis, right. The language is weakly typed in that sense, and these concessions make the life of the compiler writer much easier. So, we have to write a compiler finally. So, that is the objective of this entire exercise, and this makes it very good, right. So, this basically concludes the syntax of the Jack language very quickly, and now we will look at some small notes on the application development in the next module. Thank you.